Today we are going to discuss regarding design of clamp coupling. Okay, this is also called as split muff coupling or compression coupling. Okay, it has three different names. One, it is clamp coupling. It may be called as compression coupling. If not, it may be called as split muff coupling. Okay, here the difference between muff coupling and split muff coupling is that in the previous case, couple and the shafts are being tightened using the key itself. Whereas in this case, here two or n number of bolts will be used in order to tighten the couple to hold the shaft. Tighten the couple to hold the shaft. Here on the diagram, you can see that there are two bolts in a row and two bolts in a column, in a series, in a column and in a row to hold the shaft in a tight position. Okay, that means there will be no misalignment of the shaft when the shaft is rotating. Okay, this is what is going to happen in a compression couple or clamp couple. Okay, let us design it. Here in the question it was given that design a clamp couple to transmit 30 kilowatts at 100 rpm. That means here power has been given as 30 kilowatts, which is equal to 30 into 10 to the power of 3 watts. The allowable and also rpm also is being provided. Rpm will be termed as n is equal to 100 revolutions per minute. 100 revolutions per minute. And allowable shear stress for the shaft and key. Allowable shear stress, that means shear stress for the shaft and also shear stress for the key, both are equal, which are equal to 40 megapascal, which is equal to 40 newton per millimeter square. 40 newton per millimeter square. And there are the number of bolts connecting two halves are 6. That means here number of bolts has been provided as 6. Number of bolts has been provided as 6. N is equal to 6. N is equal to number of bolts, which is equal to 6. The permissible tensile stress for the bolt, permissible tensile stress for the bolt has been termed, that is here permissible tensile stress, as it is bolt I will write it as B. Okay, it is not bending stress. Okay, anyway, I will provide it as bolt only. Shear stress, tensile stress for the bolt is equal to 70 megapascal, which is equal to 70 Newton per millimeter square, which is equal to 70 Newton per millimeter square. And here, coefficient of friction between the muff and the shaft has been provided. That is, it is termed as mu. Mu is equal to 0.3. Mu is equal to 0.3. Now, this is the data that was given according to the question. Now we have to go for design of compression coupling or clamp coupling. Design of compression coupling or clamp coupling. If you see the compression coupling or clamp coupling, it consists of four different parts. It consists of four different parts. First part is shaft. First part is shaft. Okay, for designing of shaft we have to find out diameter small d. For designing of shaft we have to find out diameter is equal to small d. And second part is key. Second part is key. Okay, for designing of key we have to find out what is thickness of the key and what is width of the key. Similarly, third part is couple. In this case, you can call it as sleeve, or in some cases, you can term it as hub. Okay, it may be called as couple, sleeve, or hub. Anyway, but three terms will be relating to the same. That is, you have to determine length of the couple and diameter of the couple. And the last one it is bolt. Last one it is bolt. Okay, here if we have to determine only the diameter of bolt. Okay, if you determine these 6 parameters, that is diameter of the shaft, the thickness of the key, width of the key, length of the couple, diameter of the couple, and also thickness of the diameter of the bolt. If you determine these 6 parameters, your answer is completed. You determine 6 parameters, your answer is completed. Okay, here as per design data book, okay, for designing a sleeve, we have some formulas as per design data book. Okay, similarly, as per design data book, there are some formulas or some relations in order to find out the design of the key, that is T and W. And also L and D we can find out with respect to sleeve. T and W we will be finding out with respect to key. Okay, that means here the only two terms that you have to find out is diameter of the shaft and also diameter of the bolt. Diameter of the shaft and also diameter of the bolt. For these two, there is no relation. For these two, there are no relations in our data book. Okay, now if you see relation for the couple, that is L is equal to 3.5 into diameter of the shaft, and also diameter, that is capital D, diameter of the couple is equal to, sorry, length of the couple is equal to 3.5 into diameter of the shaft, and also diameter of the couple is equal to, it is 2D plus 13 millimeters. 2D plus 13 millimeters. Okay, that means initially you have to find out diameter. If you find out diameter, you can find L and D value. And also, if diameter is less than 30 millimeters, T is equal to 8 millimeters, W is equal to 10 millimeters. If diameter is less than 70 millimeters and greater than 30 millimeters, T is equal to 16 millimeters, W is equal to 20 millimeters. If D greater than 70 millimeters, T is equal to 24 millimeters, W is equal to 30 millimeters. Okay, these three are sufficient for us, not more than these three. Okay, here see, all the things are related with respect to diameter of the shaft. All the things are related with respect to diameter of the shaft. In order to find out diameter of the shaft, the thing is that first we have to find out, or first we have to design the shaft. That means here as a first part I am going to design of shaft. I am going to design a shaft. Okay, in order to design a shaft, we have a formula, that is first, in order to do that, first we have to find out the torque. In order to design a shaft, we need to find out the torque. In order to find out the torque, what is being provided in the question is power and also RPM. Thereby, power is equal to 2 n t by 60. 2 pi n t by 60. Okay, this you will be getting a answer in Newton meters. Newton meters, but I have to convert this into Newton millimeter, which is equal to 10 to the power of 3 Newton millimeter. This whole value should be multiplied into 10 to the power of 3 Newton millimeter. Anyway, I will show you this later. Let us find out our answer. Let us substitute things. Thereby, here we want to find out torque. We don't know what is torque. Thereby, torque is equal to 60 into P by 2 pi n, which is 60 into P value is being provided in the question, that is 30 into 10 to the power of 3 by 2 into pi into n value is also being provided in the question, that is 100 rpm. That is 100 rpm. Okay, now if you find out the P value, can anybody give me the answer for finding torque value? T value, how much is T value? Okay, T value is equal to 2865 into 10 to the power 2865 Newton meter. But I don't want value in meters because all values are in millimeters. All units are in millimeters. So that I have to convert this value into millimeter. Thereby, T is equal to 2865 into 10 to the power of 3 Newton. What is torque value? I found out what is torque value. Okay, after finding out torque value, we have to find out diameter of the shaft. In order to find out the diameter of the shaft, we have a relation, that is torque is equal to pi by 16 d cube into shear stress. Okay, shear stress of the shaft. Shear stress of the shaft. We are discussing about the shaft, thereby shear stress of the shaft. Okay, in the question it was not mentioned that material of shaft, couple or other components are not same materials. It was not provided in that way. Okay, okay, thereby I have to consider only shear stress of the shaft. Okay, there is no information that all materials are different or all materials are same, or components are material of all components are same, or materials of all components are different. That was not being provided in the question. So anyway, it was in the question, it was given that shear stress of the shaft, I will be considering shear stress of the shaft only. Okay, next, here we know torque value. In this formula we know what is torque value, we know what is shear stress value as it is given in the question. Okay, if you substitute, you will be getting diameter cube. Thereby diameter cube is equal to 16 into T by pi into shear stress, pi into shear stress. Okay, which is equal to 16 into torque value we have already found out, that is 2865 into 10 to the power of 3 by pi into shear stress, pi into shear stress. How much is the shear stress value that is given in the question? It is 40 Newton per millimeter square. So that it is 40 Newton per millimeter square, 40 Newton per millimeter square. Thereby, if you calculate, you will be getting D is equal to, you will be getting D is equal to 71.4 millimeters. Okay, anyway, I will consider it as it is near to 72, I will consider it as 72 millimeter. If you want, you can consider the same value. If not, you can consider in this way also. That is 72 millimeters. Diameter of the shaft is equal to 72 millimeters. Okay, here as we have found out diameter of the shaft, okay, here you can directly find out diameter of the couple also, that is diameter of couple. Here diameter of the couple, capital D, is equal to 2D plus 13 millimeter. We have already we have this formula. Thereby you can directly find out the diameter of the couple, that is 2D is nothing but 2 into 72 millimeters plus 13. Okay, which will be giving us diameter of the shaft is equal to 163 millimeters. Diameter of the shaft is equal to 63 millimeters. Diameter of the shaft is equal to 63 millimeters. Okay, now we have length of the couple also. Length of the couple also. Length of the couple L is equal to, length of the couple L is, just a minute. Okay, length of the couple. Length of the couple L is equal to 3.5 into diameter. 3.5 into diameter, which is 3.5 into diameter is 72 millimeter, thereby into 72. L is equal to 265 millimeters. 265 millimeters. 265 millimeters. Okay, we got length, we got diameter of the couple. Okay, even by using these values, we can find out length of the key also. That is here. If you see
Sir,
that, yes,
D value 157, sir.
capital D value 157.
Yes, sir.
What about length?
252.
Okay. See, I have found out diameter of the couple and also length of the couple. Okay. Now the thing is that I have to verify whether diameter of the couple will satisfy our condition or not. Diameter of the couple will satisfy our given stress value or not. Okay, I have to do that. But unfortunately here, shear stress of the couple or normal stress of the couple has not been provided in the question. Shear stress of the couple or normal stress of the couple has not been provided in the question. Anyway, we will go for verification. Let us see what is going to happen. Okay, verification. In order to verify, we have a formula: torque is equal to pi by 16 into shear stress of the couple into diameter diameter power 4 by diameter power 4 by d. Diameter of the couple power 4 by diameter of the shaft power 4 by d. Okay, this is the formula we have. In this formula, we have found out, we have already know what is torque value. We know what is d to the power of 4 value. We know what is d to the power of small d value also. Okay, the thing is that shear stress of the couple has not been provided. Okay, let us assume, okay, for our assumption, all materials are made up of same all the parts are made up of same material, and shear stress of the couple is equal to shear stress of the shaft. Let us assume, this is just an assumption. Okay, let us assume shear stress of the couple is equal to shear stress of the shaft. That means shear stress also being provided. Anyway, as it is a verification, we will find out shear stress of the couple. Shear stress of the couple. Okay, that is shear stress of the couple is equal to t by 16 into t by pi into d to the power of 4 minus d to the power of 4 by d. D to the power of 4 minus d to the power of 4 by d. Okay, that is 16 into shear stress. Sorry, 16 into torque value. I think torque value is given as 2865 into 10 to the power of 3 by pi into diameter to the power of 4. Diameter to the power of 4 is nothing but 157 to the power of 4 minus 72 to the power of 4 by 7 here by 72. Okay, if you find out shear stress is equal to, can anybody give me the answer for this? Shear stress of the couple is equal to, anyone? I don't have the answer. Shear stress of the couple is equal to, anyway, yes,
1.8, sir.
1.8 Newton per millimeter square. It should be less than or equal to 14 Newton per millimeter square. It should be equal to 14 Newton per millimeter square. It should be equal to 14 Newton per millimeter square. 14 Newton per millimeter square, which is being provided in the question. So, as it is less than, as the shear stress obtained as per the question is less than shear stress provided in the question. Shear stress as obtained is less than shear stress provided in the question. Hence, design is safe. Hence, design is safe. Design is safe. That means the couple that you have designed is safe, will withstand given stress strain values. Okay, similarly we have to go for design of, we have to go for design of key also. Similarly we have to go for design of key also. Okay, whatever we have found out, that is design of couple. This is design of couple. This is design of couple. Okay, now let us find out design of key. Okay, as diameter of the shaft is equal to 72 millimeters, as diameter of the shaft is equal to 72 millimeters, I have already given you assumptions. Assume thickness 24 millimeters, width is equal to 30 millimeters. Thickness is equal to 24 millimeters, width is equal to 30 millimeters. Now we have to find out shear stress and also normal stress. That means we have to verify whether shear stress and normal stress of the key will be withstanding whatever that is provided in the question. That is, now we are going for verification. Verify whether T and W value will withstand given stress and given stress values or not. Okay, for that we have torque. For that, let me change the color. For that we have torque is equal to length by 2 into W into shear stress into diameter by 2. One more for that is torque is equal to L by 2 into T by 2 into shear stress into diameter by 2. We have these two formulas. By using these two formulas, we can verify whether it can withstand given stress or not. Okay, just substitute the values. That is, we have torque value, we have length by 2 value, we have even length value, we have W, that is width of the key, we have diameter of the shaft also. Just we have to find out shear stress. T by L by 2 into W into D by 2. Whereas here also, it is normal stress in this case. In the second case, it is normal stress. In the first case, it is shear stress, but in the second case, it is normal stress. Thereby, normal stress is equal to T by L by 2 by T by 2 by diameter by 2. Please someone calculate answers. I don't have answers for this. Calculate answers. Just substitute the values. Tau is equal to, here we have a formula that we have torque is equal to 2865 into 10 to the power of 3 by length by 2. Length is nothing but, how much is the length? 252. Length is equal to 252 by 2 into W value is 30, diameter of the shaft is 72 by 2. And here also shear stress is equal to, normal stress is equal to 2865 into 10 to the power of 3 by 252 by 2 into 24 by 2 into diameter by 2, that is 72 by 2. Okay, can anybody give me the answers for this? Shear stress is equal to and normal stress is equal to. Okay, anyway, these both values should be less than or equal to 40 Newton per millimeter square. See, here in the question it was given shear stress. That means shear stress should be less than or equal to 40 Newton per millimeter square. As normal stress has not been provided in the question, let us assume as per the Mohr circle, normal stress will be double as shear stress. Thereby it should be 80 Newton per millimeter square. Can anyone give me the answers?
Shear stress is 21.
Shear stress is 21, that is less than the question. Okay,
Normal
here if
stress
you
52.
52. Normal stress is 52. That means these values are less than the shear stress that is being provided in the question. Hence, our design is safe. design is safe. Design is safe. Hence, design is safe. Okay. Similarly, we have to go for last one, that is design of bolt. We have to go for the last one, that is design of bolt. We have to go for the last one, that is design of bolt. Okay. Now just substitute, just go for the formula in our, for the design of the design of the bolt, that is torque is equal to pi square by 16. I have already derived this formula, so I am not going to derive this formula, just I am going to write the formula, that is pi square by 16 mu into dB square into sigma into n into diameter. Okay, I will explain you that this is torque that is being provided in the question, coefficient of friction that is being provided in the question. If coefficient of friction is not being provided in the question, you have to consider 0.3 or 0.23. Anyway, 0.3 or 0.23, that is what you have to consider. dB is the diameter of the bolt, that is what we have to find out. Normal stress of the bolt that is being provided in the question, n value number of bolts, d value diameter of the shaft. Okay, the thing is that we have to find out dB square. dB square is equal to 16 into T by pi square mu sigma n into D. Just substitute the values, you will be getting dB square, diameter of bolt square is equal to 16 into torque value, it is 2865 into 10 to the power of 3 by pi square into mu value, it was given as 0.3 into normal stress, it is provided as 70 Newton per millimeter square into number of bolts, it is 6 into diameter of the shaft is 12. Okay, if you calculate this, you will be getting diameter of the bolt is nearly equal to 22 millimeters. Nearly equal to 22 millimeters. If not, you can write whatever the answer that you get as per your calculation. Okay, you can write whatever the answer that you get as per calculation. This is nothing but design of split muff coupling. If not, you can consider it as, clamp coupling. If not, you can consider it as compression coupling also. You can consider it as compression coupling also. Okay, anyway, see, this verification is not so important. You can directly go for design procedure, but I already told you that if you go for verification, definitely that will be added advantage for your presentation. And for presentation there will be marks, so you will get good amount of marks. Okay, if you have any doubts, you can ask me now.